Hello and welcome to episode 175 of Daryl Show Your Work. All right, so in this episode, I'm going to be conducting some memory forensics with an application known as Volatility. All right, so before jumping into that, I want to remind everyone to please check out INE.com's cybersecurity training and certifications, where you'll have access to red team and blue team certification training. And it ranges from a wide variety of subject matters such as penetration testing or instant response, and it'll equip you with those hands-on, in-demand experience and skill sets that a lot of employers are looking for, and that you can speak towards on a resume and at a job interview. So go to get.ine.com/Daryl, and if you use product code INF100-Brooks Tech, you'll get 10% off any of your purchases there, with the exception of live virtual trainings. So that link is in the description, the video description below, as well as the promo code. Please check it out. All right, so volatility. It's an open source memory forensics framework used by instant responders to extract digital artifacts from computers such as RAM. All right, so it allows the analyst to uncover evidence of fileless malware, hidden processes, and active network connections that vanish when the system is powered down. So, in layman terms, think of it as recovers um, um, it recovers data in use. Okay, so such as RAM, such as cache, things that can disappear once you power down your computer. So what I'm going to be doing with volatility, I'm going to be examining a Windows memory dump, and by using a framework, and it's going to extract artifacts such as those password hashes, those running processes, command line activity, loaded DDLs, virtual memory regions, network connections, registry hives, and other sort of suspicious handles that would disappear once a computer is powered down or once a session is over. And I'm also going to be performing some malware detection using some Yara scanning to identify ransomware indicators within the memory. All right, so I'm gonna start off by gathering some general information here. All right, so I'm gonna switch to a different directory here that contains the files that I need to work with. So that is located in forensics memory. All right, and then let's check to make sure that that file is there. I'm gonna do the ls command. All right, so there is my memory dump there. All right, so that's memdump.raw. All right, so this is the raw image file that I'm going to be working with that contains that memory dump. All right, so in order to use volatility, all right, I'm gonna say vol dash f memdump dot raw, and I'm gonna say windows info. Well, I gotta put a dot info there. Okay, so what this is going to do is going to gather the general information about the memdump.raw file, and it's going to be doing so using volatility. So what the dash F option is doing is it's going to specify the file path to the memory dump being analyzed. All right, so we know it's in Windows .info. So I'm gonna hit enter. Give it a few seconds to run here. All right, so we can see there's a detailed information such as the number of memory layers, system time, and other relevant data. For example, on the NT build lab line right here. All right, if we look closely, and I'm gonna highlight the part that I'm talking about. All right, so if we look closely, right here, all right, we can deduce that the operating system that was in use within this memory dump was Windows 7. It looks like Windows 7 Service Pack 1. All right, so that's the example of that. All right, so the next thing that I want to do is I want to be able to extract hash passwords and also analyze some processes. All right, so um, again, hash dumping is very important from a red teaming point of view, because that's what's going to enable us to be able to dump those obfuscated passwords and try to use pieces of software like John the Ripper or Hashcat to crack those, to cause those hash collisions in order to be able to see the plain text password that is being obfuscated. All right. So in order to do the password, with a hash dump rather, I'm gonna say vol dash f and memdump, and this time it's going to be Windows. Well, actually, I need to put the .raw. And I've done previous videos using the hash dump, doing hash dumps before, but this is my first time showing how to do so with the volatility software here. Okay, so just checking my syntax here. All right, again, so what this is going to do is going to extract the hash passwords from the SAM database within the memdump.raw file. All right, so we can see we have password hashes for the administrator account here, for the guest account, which really doesn't really do us any good. But we also have one for it looks like a user called Inferno. All right, and then we have one for a user groups called home group user. All right. So let's say that I wanted to retrieve the default auto login password for the local security authority system. All right, and using LSA dump, which I've shown on prior videos. All right, but I'm going to use it this time in conjunction with outside of Metasploit, the Metasploit framework, and using volatility. So I'm going to say memdump.raw Windows LSAdump. All right. And again, this is going to retrieve the default auto login from the local security authority subsystem. Again, that's what the LSA stands for, LSA dump. All right. So let's do so. All right. Ooh, and we got a bunch of output there. All right. So not really, not really human friendly in terms of reading the output. All right, but this is where you would get this output and you would do some try to do some manual analysis, or be able to do some sort of automated analysis of the output here. And to be able to do that, of course, you would save this into some sort of external document for some other program to be able to read it and analyze it, and you be able to come out with whatever specific information you were looking for um, from this dump here. All right, so moving on, let's say I wanted to list out all of the process that were present in the memory dump. So let's say I was doing a forensic investigation, and I wanted to see at the time in which the system was imaged. Okay, what were those running processes? Because especially if there's malicious processes, and we needed to be able to verify that there was a malicious process running at the time in which the image capture happened, then this is where we would be able to view those processes using the following command. All right, so I'm gonna say vol dash F, and then of course we're still working with memdump.raw. All right, this time I'm gonna say dash R, and I'm gonna say pretty windows dash PS list, as in process list. All right, and again, what this is going to do is going to reconstruct the timeline of activities on the affected system. So the process list command is going to list all the processes present in the memory dump dump dash R excuse me, in the memory dump. All right, and what the dash R option, what that's going to do is going to specify the format of the output. All right, so um, basically, I want the output of this to be want this to be outputted into a particular format here. We're going to see this. Hold on. Okay, so when I did the dash R pretty, it lines everything up into a neat little output here. So everything is in line. We can see the name of the process here. We can see the process ID, the parent process ID, the image the excuse me the process is running here, all right, and all of the different attributes associated with those processes as far as the create times, exit times, and et cetera, et cetera. Okay, so we could see what processes were running. So basically, this is just a detailed list of all the active Windows services at the time of the memory dump. All right, so moving forward, I want to focus on one particular process here. Let me see if I can. Uh, let's see. It was one particular process here that I wanted to. So this process right here. So I'm gonna focus on process 2852. All right. And the reason that I'm saying process ID 2852 and not necessarily the process name, because the process name, it's the same as like one, two, three, four, five, six other processes. And I want to specifically focus on the CV, the VC host dot exe file associated with this particular process ID. All right. So let's say moving forward, again, focusing on that particular process ID. Let's say I wanted to analyze the process relationships and the command line arguments. All right, so the way I could do that, I'm gonna say vol dash f memdump dot raw windows dot ps tree, or rather process tree. All right, so again, what this command is going to do, it's going to analyze the process tree from the memory dump .raw file, and the process tree command, it's used to visualize the parent-child relationships of processes running on the system at the time the memory dump file was captured. All right, so I'm going to specifically be doing this to look for to find any parent processes that were associated with process ID 2852. All right, we can see that this output is not as pretty as the last. All right, so there's one thing though I wanted to focus on, if I could find the process ID in this mess of an output. Um, I'm looking for 2852. Let's see here. Here we go. Okay, I just saw it right here. All right, so comparing process ID 2852 to the other service host.exe file. So let me find another one here. All right, so again, I'm looking here. right here where I'm highlighted. All right, so if we look here, you see how if we look at the command lines that are associated with these, right? And where the file is, where the process is being executed. They're all being executed from system 32. So system 32 here, system 32 here. All right. But when we get down to 2852, look at where it's being executed. So this is being actually executed from the program file folder. Okay. Oh, wrong. Hold on. I'm sorry. Excuse me. Wrong line. Hold on. Let me see. Hold on. There. Here we go. Right here. I'm sorry. So this is actually being, remember that user inferno that I was able to enumerate when pulling the user hashes um, from the memory image dump. Well, it looks like instead of pulling service host.exe from the system 32 folder, the system folder here, it's pulling it directly from the downloads folder of the Inferno user. All right, and that's that 2852 process. So that's immediately suspicious because service host.exe is supposed to, we look at the other iterations of those, well, that's supposed to be executing from system 32, which hosts the system files. But more than likely this is some sort of file. All right, I can't really deduce if it's malicious or not, but it's some sort of file that's masquerading as service host.exe, where it's not, because it's not executing from the right location. Again, we can see other instances of service host.exe being ran directly from a system 32, where this one's being ran from a user's downloads folder. All right, so um, let's see, moving forward, let's see if I wanted to view the command line arguments of these processes. All right, I'm going to run the following command. So I'm gonna say a ball dash f memory dump dot raw, and then windows.cmd or command line. So again, what this is going to do is going to allow me to view the command line arguments of the processes that we were just looking at here. And so the cmd line command is going to display those arguments passed to the processes that are running on the that were running on the system at the time of the memory snapshot here. All right, so let's run that. All right, so this is the output for that. All right, so let me see if I can find. So we can see here again. So this is confirming exactly what I just saw in the previous output. All right, so we can see process 2852 service host.exe again being executed directly from the Inferno users download folder, where we see the other 6 instances of those. All right, being connected being connected, I mean, excuse me, not connected, but being executed directly from system system 32. And then even though they have different command line displays, because we can see they're associated with different sorts of command line different sorts of command line arguments. All right, it's still being the service host.exe file is still being executed from system 32, where we don't necessarily see those any sort of command line arguments here um, from service host.exe, which also could be another indicator that, hey, that this particular instance of service host .exe is behaving much differently than the others. And then we could also see too, while I'm looking at it, that there appears to be another exe file being executed from the desktop of Inferno external user. All right. So again, we don't necessarily know yet if this is something malicious, but there's some indication here that something weird is going on, and that further investigation would be needed. All right. So let's say I wanted to display the DDLs or the VADs, so of this memory dump. All right, so when I say DDLs, I'm specifically talking about the dynamic link libraries, which is a file type that's used in the Microsoft Windows operating system, and it basically it contains a collection of pre-written code, the data, and resources. And then when I say VADs, I'm talking about virtual address descriptors, which are which is a kernel level data structure within the Windows operating system, used to track and manage the virtual memory space allocated to a specific process. All right, so starting off, if I wanted to view any DDL files associated with process ID 2852, the way that I would do that is I would say vol -f, and then of course memdump.raw, and say windows.dll, and then list, and then dash dash. Oop, hold on, let me correct that. My keyboard has a mind of its own sometimes. All right, PID 2852. All right, so we can see one thing we could gather from this is that the results they tend to they seem to be indicating that the process with the PID 2852 is associated with several 64-bit DDLs. All right, so, and I'm specifically pointing to, where is that? Where's the? Let me see here. Where is the indicator? Oh, here we go. Okay, right here. So if we look at like the naming convention of the DDL, we can see WOW 64.DDL, and then we see the same thing for WOW 64 win.ddl, WOW 64 CPU.ddl. Okay, so again, that helps to understand. But then we can see the same thing here under load time. All right. So again, that's something that informs us more about those dynamic link libraries that are associated with the process. Now, if I wanted to extract the virtual address descriptors from this same process, what I would do is actually I could just go back here, and I'm gonna just change a little bit of this up here. So getting rid of this portion, and then I'm gonna just change the extension here, the VAD info, and just check out my syntax here. All right, so again, what this is going to do is going to extract the virtual address descriptors information for the process ID of 2852. All right, so the main thing to gain for this though, it's just clearly just displaying various VAD entries for the process with with the PID or process ID of 2852. All right, so again, so we would probably save this output to an output file, and use it within our analysis to draw any conclusions that we may need to make about this process, determine if it's rogue, malicious, or just trying to get to the bottom of what differentiates this specific variation of service host.exe from the others that are running directly from system 32. All right, so now moving on to scanning for network activity and registry hives, all right, within the memory dump. All right. So I'm no longer working with this process in ID anymore, and I'm looking for particularly for network activity and any sort of anything in the registry hive. Still working though with the same memory dump, just moving on from this process ID. All right, so in order to scan for network artifacts within the memory dump file, all right, I would say vol. Not sure what happened there. Let's see. Dash, there we go. Dash F, and again we're still working with the same memory dump file. All right, now I'm gonna say windows.net scan. All right, again I'm scanning this the memory dump for network artifacts. I give it a few. Let's see, just double check. Yeah, it may take a few. It may take a few seconds to load the details here. Here we go. All right, so let's see. So service host, where are you? All right, so if it's a little hard to see, but the results for the service host .exe is it seems to be involved in the network activity over unusual ports, and is communicating with a suspicious foreign address, which could suggest malicious behavior. All right, so I I'm trying to find examples of this here. Yeah, it's a little hard to see here. So right here, like right here. All right. So this is an example of what I'm talking about. All right, and then we can see the service.exe process here. Another instance of this right here. All right. And again, this is the output isn't very good, but this is what essentially this is what this command though would enable us to do, to be able to identify any sort of abnormal network connections that's being used, that's being connected to any sort of suspicious external IP addresses, or any rarely used ports, um, rarely utilized ports within a network. You know, those are usually, excuse me, red flags of um, abnormal network activity that we would flag for um, potential malicious behavior. So we will correlate this information on the network with the other information that we found regarding the service .exe process, and again, that helps us to draw a conclusion about what exactly may be going on here. All right, so let's say then I want to move on to our registry hive list. All right, so let me just bring up this command here, and I'm going to change some things. Well, I could have kept that. All right, then I'm going to say dot registry. Okay, so what it's going to do, it's going to list the registry hives present in the memory image. All right, so the hive list command, it locates and lists registry hives that are located into the memory at the time of the snapshot that the computer or the memory dump was taken. All right, so All right, so each line of the output is it's going to represent a different registry hive found in the memory dump. So the disabled note in the file output column may indicate that the hive was not actively being written to at the time of the memory snapshot. All right, so this is what's going on. Again, we're checking for any sort of registry values here, so we can see again going back to our friend Inferno, we could just see what things were going on at the time. Was there anything on a registry level that may have been suspicious going on at the time that the memory was being captured? All right. So again, um, from what we're seeing with the disabled note here, that that those hives, those registry hives, may have not been being written to at the time that of the memory capture. Okay, so if moving forward, if let's say I wanted to analyze some handles here on the in the memory dump, and I wanted to scan for specifically for a variation of ransomware using YAR rules. All right. So when I say handles, I'm talking about these are abstract references used by software to access a specific system resource, such as file, memory block, or a network connection. All right. So the way that I would do that starting off is I'm gonna change this and simply say dot handles. All right, then this time I am going to be working with the same process ID again. All right, so again, so this is going to analyze specifically the handle specifically for process ID 2852 in the memory dump. And again, that handles command is going to list all the open handles associated with which each process in the memory dump from the Windows system. Again, so it's file handles, registry keys, synchronization objects, etc. All right. So if I scroll up a little bit, let me see. All right. So I have to believe. Let's see. I've been looking for a particular entry here. Okay, this is a lot of output. Here we go. Okay. So if we look here, I remember when I said starting off, I said, I wanted to see if I could look for any sort of indicators for any sort of variation of ransomware. All right, so this if we look at this particular entry here, all right, we see the very last word on here is Locky. All right, so this particular part of the result here, it, it it's going to highlight excuse me, a handle that's pointed towards our register key, and it seems to be suggesting that the system may be compromised by something called the Locky ransomware. All right, and it's known to create a registry keys such as this. All right, so it's some things that as an analyst. You may be looking for a particular. If we're going to look at the registry, you may be looking at particular entries that are known to be malicious. You probably wouldn't do so manually like I'm doing here. It's probably some automated method in which you would probably just scan the output. Once you gain the output from the previous command that I just ran, then you would probably scan the output here, and there will probably be some automated system, something to be able to show you, hey, these are some of the malicious looking register keys that are associated with ransomware or any sort of malicious process. All right, so in this instance I was able to manually find um, a registry key entry that was synonymous with a piece of ransomware known as Locky. All right, so The next thing I want to do is I want to conduct a um, a Yara. I want to be able to use a Yara rule to scan this. All right, and hold on, I'm gonna write out the command, and once I'm done writing it out, I'm gonna explain exactly what's going on with it. I'm gonna say vol. Let's see. I want to use as much as my previous. There we go. Okay, this one's kind of long, so vad Yara scan dot dash Yara dash file. All right, do we want to scan file and directory here? Utility version 3 rules. Where then we want to specify ransom underscore yar, and then we want to specify the process ID, which is 2852. I'm not sure why it did that, but okay, whatever. Okay, so what's happening here? So I'm scanning the memory, a process ID 2852, using the ransom underscore locky dot yar rules. All right, so the yar scan, it's a plugin in the volatility framework used to scan a memory image for patterns and defined in the YAR rule. So YAR is going to help it helps malware researchers identify and classify malware samples. All right, so this is going to basically narrow down and help to determine, hey, if the entry that I just found in the memory, if it's indeed is a variation of that Locky ransomware. So let's run that scan and let's see. But just checking my syntax here really quick just to make sure I didn't goof up anything. All right, let's see. All right, and so what we can see is we can actually see various entries, all right, of that when it's saying 2852, all right, so it's specifying the process ID. And then we look here, ransom underscore Locky underscore ransomware underscore 2, all right, so it's returning that the output, and it's finding those it's finding within the YAR rules, it's finding those attributes, and it's confirming that it's found those attributes that are synonymous with the Locky ransomware malware. All right, so I was able, in this instance, I was able to use these YAR rules to conduct a YAR scan to be able to find a an instance of this variation ransomware within this memory dump. All right, and again, a lot of this will probably be more automated, but just wanted to show how this can be done manually, and just overall how volatility can be used to be able to hone in and dig a bit deep into a memory dump and be able to find a piece of malware or a malicious process. All right, so just reviewing exactly what was done in this video. So I explained the purpose of memory dumps, and how they support malware investigations, and then use volatility to gather the system information from the Windows memory dump image that I had here. And then I extracted the Windows account password hashes using the hash dump, and retrieve the LSA secrets using LSA dump, and then identify suspicious processes using the process list, process tree, and command line analysis tools, and then analyze process artifacts, including loading DDLs and BAD memory regions, and then detected suspicious network activity using the NetScan plugin. Next, I located some registry artifacts in the memory using the registry.hive list, and interpreted their significance, and then reviewed the process handles to identify ransomware related persistence indicators. And lastly, I used the YAR scanning and volatility to detect the malware patterns and confirm the ransomware presence. All right, so please like, subscribe, and share. Most importantly, show your work. Please take advantage of those discounts within those exclusive discounts with INE. Again, gaining those hands-on experiences um, that employers are looking for. Again, that you can speak towards in a on a resume or in an interview. And until next time, take care of yourself and God bless.